Yeah, so this is being recorded. So I'll start the parent meeting right now. So yeah, I'm Arvind. So I'm the teacher for 401. Um, yeah, um, and yeah, and I'll just let me know if you want to unmute. But yeah, so I'm the teacher for 401. And the focus, yeah, so I'm gonna view the syllabus. The focus for this semester is going to be in dynamic programming. So this is one of the 401 is one of the classes that's meant for like foundations for topics related to USICO silver and gold. And this is a dynamic programming course. It expects that you already know some basic dynamic programming, and it goes deeper into some concepts. So certain things we're going to go over are like dynamic programming on trees and dynamic programming on directed acyclic graphs. Technically, many DP problems can be viewed as DAG problems. And then we're gonna cover bit mask dynamic programming, and then dynamic programming on digits, and then range dynamic programming, and also some counting problems that involve dynamic programming. Um, yeah, so I'm gonna play the parent meeting video that we have for the first week. Yeah, and this is recorded.
Hi, everyone. Welcome to the first parent meeting. In this meeting, I'm just going to quickly talk about some of the useful information to make sure that you're informed and that your child can be successful in XCamp. So the first thing to note is that there is some class information in the information tab. So if you're in the courseware for your course, and you click on information, you'll be able to see some information such as the teacher, the class coordinator, link to the class, link to homework night, and other information like that. So please make sure that you know that under that tab, there's some helpful information. And then additionally, another place for helpful information is in the syllabus. Now, the syllabus is located in the course content for the class, and that just has an overview of the course content, along with some of the topics that are going to be taught in the class, and potentially even an introduction into what will be taught in the next class. Now, how do XCamp classes work? Well, currently we have all our classes conducted online in Zoom meetings, and the students are expected to have their webcams turned on in class, specifically with the camera facing their face so that we can see them. Now, all the students are encouraged to proactively engage in the class, and that's just through answering questions or participating in breakout room discussions, or participating in some coding practice, whether that's in discourse or separately assigned by the teacher. So there are lots of ways that students can participate during the class and are expected to participate. Now, after the class, students will be assigned a homework exercise. And those homework exercises are a little bit different than if you're used to completing your homework assignments at school. So usually with the homework assignments at school, they're a little bit quicker and there's probably more problems and it's a little bit easier to get full points, where the students are expected to get full points on their first try if they understood the course content. And I just want to tell you that with coding, that's not quite the case. Even if you understand the content, it really takes some time to practice it. And you should not have the expectation that you're always going to get 100% during the week on your very first try. We really value upsolving, and that's just this idea of once you've tried the problem, going back to see if you can try it again until you get your 100% on the question or 100% on your homework. Now, that often will be beyond just the week that you were expected to work on the homework. However, it is important to note that we will contact parents if the homework scores for a specific child is really low for 2 weeks. So if a student is failing to do their homework, or just solving a couple questions on the homework and really missing out on the bulk of it, that's when we will contact you and make sure that you are up to date and we can find some solutions to help your child. Now, we have a problem-solving process, and this is what we expect our students to follow. Now, they might choose to do so in a different way, but this is really what we recommend, which is first trying to read the problem carefully, maybe even a couple of times, trying out some sample input and output on paper to make sure you understand the question correctly and make sure you have the right idea. Then think about how to solve the problem using what you learned in class. The homework problems will always connect to what we learned in class, but maybe you just have to think back and think a little bit creatively. Additionally, you can watch the homework explanation video if you need. We have hint videos and solution videos to help you get through that process. Use a pencil and paper to outline your plan on how to solve the problem, depending on the problem's difficulty or how well you understand it. And then also code your solution, test with different cases. A lot of times the problems will just give you one test case. You definitely want to create your own test cases and see if they work as expected. And then finally submit your work. Okay, so let's go on to the next problem here, which is homework night. So homework night is hosted every single night from 5 to 8 p.m. Pacific Standard Time. And students are encouraged to join the Zoom session and work on their homework. So it is a place where you can get help, but you don't need to go to the homework night to get help. You can simply just join the homework night. It's nice and quiet, and you can just work on your homework during that time. And if you get stuck, you can ask one of the TAs for help, and they will be able to assist you. So don't feel like you have to go to the homework night with a question. You can always hang out there, and if you get stuck, then you can ask your question whenever you need it. And like I mentioned before, homework night Zoom link can be found in the courseware under the information tab. Now, the hint video and solution videos are a really useful tool for students to be able to make sure that they get full points. Oftentimes, there's just a small misunderstanding by the student on how to complete the problem. And the hint video is a way that they can clear up that misunderstanding and save them a lot of time from going down the wrong route. Now, make sure not to jump to the hint videos too soon. You really want to practice spending enough time to try and understand the problem yourself. Remember, if you're interested at all in competitions, you won't have hints or solutions to help you along the way. And the solution video will walk you through the code and show you how you can complete the problem as intended. Now, we also have a platform, Discourse. And in Discourse, this is basically a forum section where students can ask questions and either their classmates can answer, or we also have TAs who are dedicated to check for posts and answer and make sure students get the replies that they're looking for. So for this, it's student-to-student communication, and Discourse should be your priority when you have like any course-related questions. You can ask those and other students can answer, or TAs can answer. Additionally, you can also ask homework-related questions as well. Now, this is kind of a workflow diagram of how you should go about your homework. So after class, you have your homework, and if you have no clue how to start it, then you can always go to the hint video. Additionally, you can go back to the slides in class and see if you can make some connection from that. Now, if you failed a couple times and you don't really have the right idea or it's not quite working, you can then go to the solution video, which will be released after 2 days, or depending on the class, it might be slightly different, but our standard policy is about 2 days. And after the solution video, if you still are not quite understanding how the problem works or what's wrong with your submission, well, for our lower level classes, we have office hour that we offer where they can get the one-on-one TA debugging help. And for if you have a time conflict with that, or you're in a higher level class where we don't have such a need for the one-on-one help, well, we have the Discourse where you can ask questions always, and you'll get a reply within 24 hours. And then also you can just go to the homework night and also ask your questions there. Now, additionally, the student guidebook is a resource that can be used and should be used by students in order to make sure that they have all the information regarding how to access discourse, how to do some other things like download test cases or some of the rules and instructions and some other helpful information. So just make sure that in your book, you see the student guidebook content, and there it will have all that information necessary for the students to understand. In case there's always some students who have some trouble logging into discourse or things like that. Now, a really important role in terms of the class is our class coordinators. Now, our class coordinators are basically our way of following up with the students and sort of monitoring their progress and being that communication layer between the teacher and the parents. Now, there's sometimes a lot of communication or questions or things like that that parents could have, and our class coordinators are there to quickly assist you and make sure that you have all the information and all your questions are answered. And they're basically going to collect some requirements for students and parents and make sure everything is synced and we're all on the same page, and just provide a really great service for you. And then they'll also provide some other coding related information like seminars and contests and camps and other things like that. So hopefully this information was really helpful. If you have any further questions, feel free to reach out to your class coordinator or reach out to us here at XCamp in order to get those questions answered. I hope that you have a really great quarter. You enjoy our teaching, and we see you back again for the next quarter.
Okay, so just to comment on this, yeah, so some of the information here applies more to the lower level classes, as was mentioned here. Like, we don't have TAs for this class. We're more advanced class, but this course will be open for students to ask questions. And then yeah, to ask questions about homework or anything course related. And we also have a Discord server for this class. So I'll I'll share that in a bit with students. How do I exit full screen? Yeah, but yeah, that's it for the yeah. So any questions from anyone about the course in general before we start class? Oh, okay. Yeah, wait. Okay. Yeah. Okay. Yeah, I think we're good now. Okay. So if there's no questions, then we'll get started with class. Um, yeah, so let's get started with class. Yeah, so I'll move this over. Yeah. So can everyone please turn on their videos? Where can I find the syllabus? I'll actually just make it visible now so everyone can see it. Yeah, it's not visible. Yeah, so I'll make this visible and then we'll start class. Yeah. Okay. So you should all see this. You should also be able to see the syllabus. Yeah, so we'll get started with the class material. Actually, before we start with the class material, I'll just go around. So everyone just say your name, where you're from, and then what's your favorite algorithm? So yeah, I'm Arvind. I'm originally from Georgia. I'm now in Purdue. My favorite algorithm is binary search. Brian?
My name is Brian. I'm from Texas, and my favorite algorithm is uh, BFS.
Nice. Azalea?
My name is Azalea. I'm from New York, and my favorite algorithm is Kruskal's.
Nice. Christopher?
Hi, I'm Chris. I'm from Illinois, and my favorite algorithm is Dijkstra.
Owen?
Hi, I'm Owen. I'm from Seattle. My favorite algorithm is binary search.
Zishan Yin?
Xuan, I'm from San Jose, and my favorite algorithm honestly is what's it called? Brute force.
Nice. Okay. Uh, Aaron?
I'm Aaron. I'm from California, and my favorite algorithm is DFS.
Great. Arav?
Yeah, I'm Arav. I'm from California. My favorite algorithm is Dijkstra.
Zishan Ye?
I'm Zishuan, and I'm from California, and I also like brute force.
Nice. Albert?
I'm Albert. I'm from Maryland. My favorite algorithm is BFS.
Cool. Alvin?
My name is Alvin. I'm from California, and my favorite algorithm is binary search.
Nice. Justin?
My name is Justin. I'm from California, and my favorite algorithm is binary search.
Nice. Kevin? I think you're muted, Kevin.
My name is Kevin, and my favorite algorithm is BFS. I'm from California.
Nice. Injal?
Oh, I'm Jinjao. I'm from California. My favorite algorithm is probably BFS.
Cool. Wait, did I miss anyone? Okay, I think I asked everyone. Okay. Cool. Yeah, so before we start going over content, we'll have our in-class practice question for everyone to answer. So this is a motivating problem for this unit. Yeah, so I'll paste the link in Discord. I mean, in the chat. Yeah. I'll give some people some time to, yeah, write up the solution. Yeah. You don't have to write in pseudocode, just write just the idea for how you can do it. Yeah, and let me know if if you're unable to access this course. Then I'll just tell the class coordinator, and then we can fix things for you after class. But yeah, other than that, looks like people are able to access this. Yeah, I'll just wait for people to reply. Okay, great. Yeah, so many people had similar ideas. So this is a standard dynamic programming problem, where you can let dpi be the number of ways to reach stair I, and to reach stair I, you can either reach it from I minus one or I minus two. Yeah, so you get this kind of recurrence, which is dpi is equal to dpi minus one plus dpi minus two. You can also define your base cases. Yeah, good. Yeah, so this is a motivating problem for this unit. So today we'll talk about DP, and we'll be going over some problems related to tree dynamic programming. But any questions before we go over the content? Yeah, and then I think you can also use Binet's formula. Yeah, I think it's some way of expressing Fibonacci number in terms like some powers of some square root plus something. Yeah, but for n equals 10 to the 5, it's sufficient to do just use dynamic programming. Cool. Yeah, so we'll get started. Yeah. Yeah. Yeah, so we're gonna talk about DP on trees. Yeah. Yeah, so we just went over this problem in our in-class exercise. It's one of the more standard dynamic programming problems that you might have seen before. Yeah, and yeah, there's end states and there's a base case, and then there's this transition, which many of you wrote. Yeah. Just out of curiosity, just type like 1 if the answer is yes, or type 0 and the answer is no. How many of you have heard of the notion of pull DP and push DP? Just type like 1, or if you like familiar with it, 0 if no, 0.5 if in between. Okay. Okay, so I'll talk about like pull DP and push DP. Maybe not everyone uses it. I'll send this link later. Actually, yeah. Yeah. So pull DP is basically like. So the idea of pull DP is, so pull DP is you have a state. So remember DP usually has some kind of states, and then it has some kind of transitions. So example in this problem, the transition was dpi is equal to dpi minus 1 plus dpi minus 2, right? Yeah, yeah, so pull dp is basically when you want to calculate your current state, and then these are all calculated. So these are earlier states that transition to it, right? So you've already calculated dp for all of these, and then you just calculate this based on the earlier values. So here, this kind of transition is an example of pull dp, right? Because you want to calculate the dp of the current state, and you take it from dp of earlier states. Meanwhile, push dp is you assume dp has been computed for your current state, and you want to find contributions to later states, right? So how would I write this in a push dp style? Any ideas? This kind of recurrence. The push dp is my current state is already computed, and then I want to find the contribution to later state. Yeah, yeah, good. So instead of writing it in terms of your earlier states, you can yeah, so you can let this be dpi, and these are your future states. You can find the contribution of the current state to the future states. So it's going to be something like dpi plus 1 plus equals dpi, and then dpi plus 2 plus equals dpi, right? So this is a push dp style of writing transitions. And in many cases, you can do either one or the other. Sometimes one might be easier to think about than the other, but yeah, it's good to know. Like you'll see a lot of people like implementing things either this way or this way, depending on the problem. Yeah, any questions? Okay. Yeah, so throughout the quarter, yeah, a lot of our solutions, or a lot of the solutions in the slides, some of them might use PullDP, and then others might use PushDP. But in many cases, you can use either, and it's good to know they exist. Right. Yeah. 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 So yeah. We can write it like this. So PullDP is DPI in terms of its earlier things. I might have not just, yeah. And then PushDP. Of course, you also just set the base cases somewhere else, but you have these transitions like the current state contributes to a later state. Like these two lines here, right? Yeah. Oh, okay. One more question. What structure, like in any DP problem, what can you usually say about the structure of the states and transitions? Is there anything special about the structure of states and transitions? So for any DP problem, is there anything special about the structure of states and transitions? Just for, yeah, it's a DAG, right? So DP problems is basically some kind of DAG, which is directed acyclic graph. So usually when we're talking about DP, our transitions are not like this. Of course, you'll find problems where you're dealing with something transitions that are cyclical, but in many cases when we do dynamic programming, we assume like it's very nice to assume that the transitions are not cyclic, right? So this is a cyclic graph, so it's not acyclic. So it's gonna usually the transitions might look something like this, right? And usually it's like a special type of directed acyclic graph. So in the stairs problem, you just go from I-1 and I-2 to I. So basically all the transitions are just leaps of length 1 or 2. Yeah. Yeah, so we're gonna do a problem. Yeah. Yeah, so given a directed acyclic graph on n vertices and m edges, find the length of the longest path from vertex 1 to vertex n. And you can assume there always exists a path from vertex 1 to vertex n. Yeah, I'll wait for people to come up with ideas.